This is Deepti Verma in front of you, and today in this module we are going to study again a very interesting topic, that is about the phase rule. And this is the important generalization dealing with the heterogeneous system. And this topic was given by American physician Willard Gibbs, so it is also known as Gibbs phase rule. And mathematically it is represented as P plus F equals to C plus 2. I am drawing P plus F equals to C plus 2. And the formula is P plus F equals to C plus 1. It is for the one component system, while another is for the two component system. So in this topic we will study about the one component system by taking the example of the water system. So our main topic is we have to study this water system. So before getting knowledge that what is the water system, we have to study these terms, that what are these terms. Because in water system we have to basically find out the degree of the freedom, we have to find the value of F. So before knowing, we have to understand that what is F. So let us see P. P refers to the number of phase. Another thing is F, which refers to the degree of freedom. Another term is C, which is the number of component. So we can say that phase, degree of freedom and component forms the phase rule. It is a basic concept. So let us see that what are these terms. First is phase. Phase. It is the homogeneous composition in which all the physical and chemical composition are in same thought. For example, if we take the example of the water, then we see that water exists in the three phases: solid, liquid and gas. It means that if it is a solid state, so it has all the composition, physical as well as chemical properties, all the properties are of solid like, while in liquid and in vapor form, it has the property of the constituent substances of the constituent phases. Got it? Next thing is about the F, and it is very important term, F. That is the degree of the freedom. And basically we have to calculate this term, that is degree of the freedom, so we have to know that what is the degree of freedom. So degree of the freedom, it is the minimum value, or we can say it is the minimum variable factors which produce an effect, or we can say it is a minimum value or variable factor which is necessary for the phase rule system. It is a very necessary component. And another thing is C, means number of the component. It is the minimum unit which is required to complete the phase rule. We can say that if we go through the component, then CaCO3, calcium carbonate, which is dissociated into calcium oxide and carbon dioxide. So these are the smallest constituents or smallest molecule which is required to complete the phase rule diagram, or which is required to define the system completely, or to identically, it has the identity to define the phase rule. Okay? So this is all about the basic concept of the phase rule. We have get the idea that what is the phase rule. Now, our main topic is we have to understand that what is the phase rule diagram. By taking the example of the water system, we have to study the one component system. So let us see that what is the water system. So for this, I am drawing the figure phase rule diagram. It is a graphical representation of temperature and pressure. So it is a temperature and pressure graphical representation. And we know that water exists in the three phases: solid, liquid and gas. I am marking the point. This is point O, this is A, C, B. These are the points, and all the phases have the water. It is in a solid state, it is in a liquid and it is in a vapor state. So this is the graphical representation. Now let us see, from this figure what we observe, from this figure we conclude three things. First is curve, another is area, and next very important topic and very important point is third point, that is triple point. is very important topic because from this topic, this question is asked many times, and the question arises as, does all the three phases of the water system can coexist? So the answer is yes. All the phases can coexist. How all the phases can coexist? We will see later on. So before knowing this, we have to understand these two, that what are curves and what are areas, and how we have to calculate the degree of the freedom. So curves, they are curves OA, OB and OC. These are the curves. OA, OB and OC. These are the curves. Another thing is area. Area is AOB, BOC and AOC. These three are the areas. And another thing is triple point, that is O. This is the triple point O. So these are the different terms, and in this. In all the cases, we have to calculate the F, degree of the freedom. So let us see how we calculate. Let us see in the curve. Let us take the curve. First, we take OA curve. In this OA curve, what we observe in this curve, we observe that it is a temperature and pressure, or we can say vapor pressure variation graph, or it depends upon the temperature pressure representation. And in this, we observe that initial point is O and the final point is A. At the initial point, it exists in a solid state. It exists in a solid state. It exists in an ice state. While if we move throughout the A, then we got the liquid state. It means that state changes from one form to another, and where vapor merges between the two states. So in this, what we observe that OA, in which the vapor merges these two states. It means that here the number of phases is 2, because it merges between these two states. So here the number of phases, here P is 2. And as we are studying about the one component system, this is about the one component system by taking the example of the water system. So component becomes 1. Now applying phase rule, what we get? Applying phase rule, we have to calculate degree of the freedom. Applying phase rule, P plus F equals to C plus 2, where F equals to C minus P plus 2, where C is 1, P is 2, and this constant term is 2. So this and this will cancel out, and F becomes equals to 1. So here degree of freedom is 1. It means that the system is univariate. It means that among temperature and pressure, one of the factors create an effect to change from one state to another state. Got it? So this is about the OA curve and how to calculate the number of degree of the freedom by applying phase rule. In the same way, if we move through the OB curve, then what we observe that in OB curve, it is first in solid state, while as we move towards the B, it changes into vapor state, it changes into gaseous state. It means that it changes from solid to vapor phase. It means that this is a sublimation curve. And we know that what is sublimation directly changes solid into the vapor form, so it's known as sublimation. So this curve is also known as sublimation curve. So here also we get that these two phases get merged. So here also phase becomes 2 and number of components becomes 1, and by applying the phase rule we get the same result, that F, or the degree of freedom, becomes equals to 1. So this is also the univariate. Moving to the next, that is OA curve. In this curve what we observe? In this curve we observe that here liquid and solid phases merge one another, and it is also the melting point curve. And here we apply the phase rule where P is equals to 2 and C equals to 1. By applying the phase rule, we again get the same result, that F, or the degree of freedom, become equals to 1. Got it? So this is all about the curve, that how to calculate the degree of the freedom of the curve. And from here we conclude that when we classify it on the basis of the curve, then we get the univariate. It means that F become equals to 1. Among temperature and pressure, one of the factors create an effect. So this. And another thing we observe that phase is inversely proportional to the degree of the freedom. Number of phase increases, so degree of freedom decreases, and if it increases, then this decreases. Got it? Now, moving to another thing, that is area. So how to calculate the area? Let us see. Another thing is about the area. So first area is area AOB. Area AOB. In this, we will observe that a particular phase is confined in a particular area. Here, this area is enclosed by the vapor phase, this area is enclosed by the liquid phase, and this area is enclosed by the solid phase. So here, all the areas are confined in a particular phase. Got it? Now, let us see. By taking the example of area AOB, in this AOB, it encloses within the vapor phase. If we observe through this, so it has only confined with the vapor phase. It means that here P, number of phase, equals to 1. Because here, if we look through this area, then we get 1 phase. And here, what the phase we get? Vapor phase. A gaseous state we get. So here P becomes equals to 1. And component, we know that we are studying about the one component system. Now applying the phase rule in this. Applying phase rule. What we get by applying phase rule? P plus F equals to C plus 2. Where F equals to C minus P plus 2. Now here C equals to 1, P equals to 1 and 2. So these will cancel out and F become equals to 2. So in this, what we observe that the degree of the freedom is equals to 2. It means that both the temperature and pressure creates an effect. It means that the system is bivariant because both the factors produce an effect. Got it? In the same way, if we look through the area AOC, so it is also confined in a particular area, that is liquid state. While if we see that area BOC, it is confined in a solid state. So when we apply the phase rule, we get the result F equals to 2. This is clear to you? Okay. And the last and very important point is the triple point O. Let us see what is this. This is the triple point and I have marked it O. And in this point, we will observe that it exists in all the three phases. It has the connection with the solid, it has the connection with the liquid, and it has the connection with the vapor form. So it has all the connections from all these sides. So that's why it is known as the triple point, because it exists on all the three phases. And we can say that all the three phases can coexist in this O point. Got it? So it is known as triple point. And in this, when we apply the phase rules, then what we get? Phase rule. If we apply phase rule for a triple point, then we get P plus F equals to C plus 2. And in this, T becomes equals to 3. Why it becomes equals to 3? Because all the phase can coexist at a point O. That's why it becomes equals to 3. Now let us see F equals to C minus P plus 2, where F equals to 1 minus 3 plus 2. So it becomes equals to 0. Here the factors or the external factors or the degree of the freedom become equals to 0. It means that among temperature or pressure, no any effect is created. And due to this point is also known as metastable point. How much we increase the temperature, how much we increase the pressure, it doesn't have any effect. It exists in all the phases. Coexistence takes place. That's why it is very important point and it is asked many times. So this is all clear to you? And this is all about the phase rule. And I think that you get knowledge from this. And wishing all the best.